Welcome back to Mr. DuPage's classroom. This lesson is for my Algebra 2 class. This is 2.2, Graphing Quadratics in Standard Form. The properties of a parabola for f of x. Remember, f of x just really means y. A times x squared plus bx plus c, where a, b, and c are real numbers, just means they can be any number on the number line, and a is not equal to 0, the parabola has these properties. The parabola opens upward if a is greater than 0 and downward if a is less than 0. Well, let's talk about what a is to begin with. A is going to be the number that is attached to x squared. It can be a 1, a 2, a negative 1, a negative 2, a negative 1,000 for all we know, okay? The axis of symmetry is the vertical line x when it equals the opposite of b. Well, we just talked about what a is. B, if you look up here, is going to be the number that is attached to the x. Okay? So we're going to use the opposite of that number and divide it by 2 times our a value that we just talked about. The vertex is the point, well, the vertex is going to be our axis of symmetry is going to be our x value. Our y value is going to be where we take the x value, whatever that ends up being, plugging it back into the original equation for all the x's, and we will find our y. The y-intercept is our c. Our c is the number that sits out by itself. If there is not a number for our b value, or our c value, we will input 0 for that number, okay? So let's get right into a problem. Hopefully after you see the problem, it will help you out, okay? The problem is f of x is equal to x squared minus 4x minus 3. The first thing that I want to do is, right now I do not have a number where my a value should be. So what I'm going to do is, anytime there is nothing in front of a variable, we can always plug in a 1. Okay? So we need to determine what our a value is. Remember that a is going to be the number that is in front of our x squared. In this case, it would just be 1. B is going to be the number that's in front of our x. Well, that's going to be this negative 4. And C would be the number that's by itself. That would be this negative 3. Okay? Remember that the parabola will open up if a is greater than 0 or positive, and it would open down if a is negative. In this case, our a is positive, so it would open up. Find the axis of symmetry. Remember from our little table above that our axis of symmetry, our AOS, is going to be x equals the opposite of our b value. So how I'm going to write that, especially when I have a negative b value, is I want to do negative parentheses negative 4 over 2 times my a value, which in this case is 1. Okay? Well, I can have a negative 1, distribute that. That would give me a positive 4 over 2 times 1, which is 2. 4 divided by 2 would be 2. That is my axis of symmetry. So x would equal 2 is my axis of symmetry. In order to find my vertex, I would have a plotted point, or a coordinate. The coordinate is always x first. Remember that I'm going to take this axis of symmetry and plug it in for my x. So 2 would be my x value for my vertex. All right? In order to find the y, or the missing point, missing number of my axis, or vertex, what I would do, I'm going to rewrite that for you so you can see it better, is I'm going to take 2 and plug it back into the original equation for all of my x's. The easiest way I've found to do that is to rewrite my problem, and everywhere there is an x, I'm going to put a parenthesis. So I'd have 1 parenthesis squared minus 4 parenthesis minus 3. So I've rewritten my problem. I've taken out all the x's and just put a parenthesis in its place. Now what I'm going to do is, I know that this 2 is my x value, so I will put 2 in for all of the parentheses. Okay? I can type that straight into my calculator. but I want to type it exactly the way it looks right here. So I would type 1 parenthesis 2 parenthesis raised to the second minus 4 open parenthesis 2 close parenthesis minus 3. That's going to come up with a number. The number in this case would be -7. So my vertex is going to be 2, -7. Let's talk about how I can use that to fill in a table. When I fill in a table like we've talked about before, the vertex is going to go right into the center, and then the rest is exactly like when we graphed and filled in tables for vertex form. Okay? But I did skip a step. It is step 5, determine your Y-intercept. Remember that our Y-intercept is just going to be our C value, which in this case is -3. So Y-int will be -3. Okay? So just like we did when we filled in tables when we had vertex form, in order to fill in the rest of my x's, I will add 1. So that would be 3. Add 1. That would be 4. Going the other way, I would subtract 1. So this would be 1. Subtract 1. This would be 0. Remember that your Y-intercept is the Y value when my x is 0. Okay? So I can just go ahead and plug -3 into that location. And if you remember from vertex form, this is going to be exactly the same on the left-hand side as it is on the right-hand side. So underneath that 4, I can go ahead and just write -3. The only thing I have to do now is plug in either 1 or 3 in for my x's to find that y. So y would equal, remember to rewrite your problem with parentheses where the x goes. And I'm either going to use 1 or 3. Me personally, I always use the number to the right of my vertex, so I'm going to use 3. I could type that straight into my calculator, and the number that comes up will be -6. Now, we did say this parabola will open up. So let's take all of the information that we just found to to make our graph, okay? We know that our parabola should open up. Excuse me. So I'm going to draw a little arrow here to know that my graph should open upward. So my axis of symmetry I need to graph right now. That is going to be at 2. So I need a vertical dotted line at 2. If you do not have this dotted line, it will count off, okay? My vertex was at 2, -7, so I want to plot a point at 2, -7. There's 2, -7 right there. The next point is going to be at 3, -6. Well, 3 is one spot to the right of my 2, okay? So -6 from there will be right here. Remember that this should be the same on both sides, so I can just come over one spot and plot that point. Now I need to go to 4 and down to -3. So -3 would be right here. I can go one more spot to the left and plot that point. Okay? From here, all I need to do is connect my points. I have a U that opens up, so I know that this should be fairly close. The final step is to determine our domain and range, just like when we did vertex form. Our domain would be all real. Our range would be, since it opens up, y would be greater than or equal to the y value at my vertex, which is right here. Remember that my vertex was 2, -7, so y would be greater than or equal to -7. All right, let's move on to example number 2. It's going to be the exact same steps every single time. So if you get into this flow, into this system, then you will understand how this works. Remember what I said early in the video, that if I do not have a b value or a c value, then I want to go ahead and put those in. So I'm going to rewrite that equation as f of x is equal to 1x squared plus 0x plus 2. Okay? So now I should have an a, a b, and a c. Well, my a is going to be the number that is attached to my x squared, so a equals 1. My b is the number that's attached to the x, so b equals 0. And my c is the number that sits by itself, so c equals 2. Once you get the hang of this, you'll realize, without having to rewrite the equation, that your b value is just 0. So will the parabola open up or down? Well, is my a value positive or negative? Since it is positive, this graph will open up. Find the axis of symmetry and draw on the graph. What I need to do for axis of symmetry, remember, it is my AOS. X will equal the opposite of b. Well, my b value is 0. So it's the opposite of 0 over 2 times my a value, which in this case is 1. Well, the opposite of 0 would just be 0. 2 times 1 would be 2. 0 divided by 2 is going to be 0. So for my vertex, my x is 0. I would put 0 back in for all of my x values. So y would equal, remember to put parentheses wherever an x shows up, plus 2. 0 squared is 0. Remember, I need to take the 0 value, plug it into the parenthesis. 0 squared would be 0. 0 plus 2 would be 2. So my y value is just 2. Finally, we need to determine the y-intercept. Remember, the y-intercept is just my c value. So my y-intercept would be 2. Okay? And actually, when we write the y-intercept, what I want to do, I haven't done this yet, please pay attention. When I write my y-intercept, I want to make it a point. So I need to have a coordinate. Okay? 2 will be the y coordinate. But what is my x when I'm at my y-intercept? Well, my x would be 0. So in this situation, my vertex and my y-intercept will be exactly the same. Okay? My axis of symmetry in this problem was 0, so I need to have a dotted vertical line at x equals 0. I want to put my vertex in the center, and I also want to plot my vertex on the graph. So 0, 2 is right there. Remember, going to the right, I add 1, so that's 1. Add 1, so that's 2. Subtract 1, that's negative 1. Subtract 1, that's negative 2. Okay? In this case, I can't just take the shortcut like I did on the first problem, so I need to take 1 and plug it into my original equation. This would be y equals, use parentheses wherever there's an x, squared plus 2. I'm going to take 1, plug it in for x. 1 squared is 1, 1 plus 2 is 3. So where it's 1 and negative 1 will be 3. The next thing I want to do is take y equals parenthesis squared plus 2. Again, that's just my original equation, but instead of an x, I've put in a parenthesis. I will put 2 in for x. 2 squared is 4. 4 plus 2 is 6. So where it's 2 and negative 2 will be 6. The last step, or the next step, is to plot the points and draw our parabola. So I would go to where x is 1, which is right here. Y is 3, which is right there. Where do they cross? Right in that location. Remember, both sides will be even, so I can go across the other side of my axis of symmetry. Then I need to plot the point 2, which is here, and 6 is there. Where do those cross? Right here. Again, just bring it across the axis of symmetry. Draw my graph, and there we go. It was supposed to open up, right? It does open up, so this is looking good so far. The last step is to determine the domain and range. Well, my domain would be all real. My range would be y. Since it opens up, it's going to be greater than or equal to. What is my y value at my vertex? It is 2, so y is greater than or equal to 2. Let's go ahead and go to the Third example. Now it has taken away your little helpers. It has taken away telling you what each step does. But we can talk through what each step does. The first step is to figure out my A value, B value, and C value. Well, my A value is going to be this -2. It is what is attached to the x squared. My B value is going to be this 4 because my B is what is attached to the x. And my C value will be 1 because that is the number that is by itself. The next step was to say whether the graph would open up or down. That comes from my A value. Is it positive or negative? In this case, it is negative, so my graph will open down. Step 3 was to find my axis of symmetry. Axis of symmetry is x equals the opposite of B, which is positive 4, so I can just write -4 there, over 2 times A, which is -2. This would be -4. 2 times -2 is also -4. So my axis of symmetry is x equals 1. What was step 4? Well, step 4 was to find my vertex. Remember that my x value of my axis of symmetry is going to go in for my x. I would need to take and rewrite my original equation. In place of all the x's, I will put parentheses. So it would be -2 parentheses squared plus 4 parentheses plus 1. I'm going to take my axis of symmetry and plug it in for the parentheses. So this would be 1 and 1. Well, 1 squared is 1. Again, you can type this straight through in your calculator. If you do type this straight through in your calculator, what you're going to end up with is +3. So my vertex is 1, +3. Step 5. What was step 5? Well, that was to find my Y-intercept. Remember, I just talked about this in the last example. I want to make my Y-intercept a coordinate. At my y-intercept, my x is always 0. So what was my y-intercept according to my a, b, and c? It is always my c value, which in this case is 1. So my y-intercept will be 0, 1. I want to put my vertex in the center. So 1 goes in for x, 3 goes in for y. Going to the right, I add 1, so 2, add 1. 3, going to my left, subtract 1, 0, subtract 1, -1, right? Well, I know that when my x is 0, my y is 1. So I can put 1 in for 0 and 2, being that they are going to be exactly the same on either side of my axis of symmetry. I need to figure out what my y value will be when my x is 3. So again, I'm going to rewrite this with parentheses where my x value should go. Just rewriting the original equation. Everywhere an x shows up, I just put a set of parentheses. I will take 3 and plug it into where my parentheses show. I can type that straight through on my calculator. If I do, I will end up with -5. And being that it is symmetrical, that will also be -5. My -1 would also be -5. Now for the graph. What was my axis of symmetry? It is when x is 1. That is right at this location. So a vertical line at x equals 1. Okay? My vertex is right here. It is 1, 3. So remember x is 1 there. Y is 3 there. So here is my vertex. I need to plot the rest of the points. Well, x is 2 at this location. Y is 1 at that location. They cross right here. It needs to be symmetrical, so I can just bring it across the axis of symmetry. For my last 2 points, x is 3 here. Y is -5 there. Where do they cross? Right there. And again, I can bring this across my axis of symmetry. Go ahead and connect all of your points. according to step 2, my graph should have opened down. It does, so again, so far, so good. Okay, the last step, and don't forget this step. A lot of people in the past have. It is my domain and range. My domain is always all real. My range is going to be y. I need to know whether it's going to be greater than or less than. Well, since my graph is opening down, it will be less than or equal to. I will use my y number at my vertex. So it would be y is less than or equal to 3. All right, well, that is the end of our lesson. Remember, in order to find your a value, it is the number that is attached to x squared. Your b value is the number that is attached to x, and your c value is the number that sits by itself. In order to figure out if the parabola opens up or down, we need to look at our a value. If our a value is positive, our parabola will open up. If our a value is negative, our parabola will open down. The axis of symmetry, we take the opposite of our b value and divide it by 2 times our a value. The vertex, we're going to take the x from our axis of symmetry, plug it back into the original equation to find our y for our vertex. The x portion of our vertex is going to be just our axis of symmetry, and our y will be whatever number we calculate. Okay, the y-intercept is your c. Remember to place the vertex in the center of your table, and after you have graphed it all, double check that your graph opens the correct direction, and finally remember your domain and range. Your range or your domain will always be all real or the double bar r, and your range will be y is greater than or equal to if our graph opens up. It will be y is less than or equal to if our graph opens down, and the number you use there is your y value from your vertex. Thank you very much for watching the video, and if you have any questions, make sure you ask tomorrow. Have a great day.